Let's look at how to differentiate a new type of function that we've not differentiated before. So we're going to look at a way to differentiate a number to the power of x. So a could be any number, it could be 2 to the power of x, could be 3 to the power of x. So far we know how to differentiate some sort of exponential functions. Like we know that when we differentiate e to the x, actually I should just probably start with the basics. Like this is the most important thing about this function from A-level maths. If we've got y equals e to the x, dy by the x is just e to the x. That's like why we care so much about it. It's like this special function that when we differentiate it, it stays the same. Don't forget e is just a number. It's just like 2.71828 ... So what we're really doing here, without you maybe realising it sometimes, is you've just got numbers to the power of x, and when you differentiate it, this one, it stays the same. But for different numbers, something slightly different happens. Okay, so we're going to do a show question to start with, and we want to show that when we differentiate 2 to the power of x, we get this. Now the way I'm going to do this, I'm going to start by writing it as y equals. So if we define it as a function, we can do some rearranging before we differentiate it. I actually can't differentiate this at the moment, I don't know how to. So what we can do is there's a trick where we can rewrite it in a slightly different way. And what I'm going to do is I'm going to take the natural log of both sides. So I'll apply the ln to the left hand side and the ln to the right hand side, because you can do that, can't you? As long as you do the same thing to both sides, that's fine. Okay, now the reason why I'm doing that is if I take the natural log on the right, this power I can use a log rule with, so I can write it as x ln 2. Now we've actually got something that we can differentiate. Okay, I'm gonna differentiate both sides with respect to x. So if I differentiate with respect to x, ln y, I'm going to differentiate with respect to x ln 2. Maybe just pause for a second and think about how you're going to differentiate both sides. One thing to notice, right, there's actually two things going on here. Let's look at the right hand side first. ln 2 is just a constant. That is just a number. So I know it looks a bit weird because you've got the x at the front, but that is just a number times by x. And you all know how to differentiate that. If you differentiate a number times by x, you're left with just a number. Okay. On the left hand side, the way I'm going to do it is using this implicit differentiation. So remember, if you've got a function, so if I differentiate y squared, we differentiate y squared, we get 2y. But because it's a y function with respect to x, we multiply by dy by x. So I'm going to use the same rule on the left hand side. So I differentiate ln y, I get 1 over y. And then because it's with respect to x, I'll just times by dy by dx. Okay, so have we got the final answer? We're trying to get 2 to the power of x ln 2. So if I start off with y equals and it says the derivative, all we need to do is rearrange. So what would dy by dx equal? Because that's going to be my derivative, isn't it? So dy by dx would equal y times ln 2. But we're in the world of y. We need to link it back to the world of x. And like literally that's all we need to do is look at the original question that we wrote. We said, well, y is just the same as 2 to the x. So this would give us our result. 2 to the x ln 2. Let's do another one, because I feel like there was a bit going on with that, right? The general rule, so if I had y equals a to the x, so any number, then let's write it as ln y equals ln a to the x. ln y, bring the reason why we're taking logs is so we can bring the power down. X ln a. Differentiate both sides with respect to x. So we differentiate this side with respect to x, we'd get 1 over y dy by dx. Differentiate this side with respect to x. Remember, you've just got a number times by x, so you're left with the number when you differentiate. So dy by dx would equal y ln a, and we know that y is equal to a to the x. So that is like a general result that you want to keep in your notes. And unless it's a show question, right? If it's not a show question, if it just says differentiate, you can use this. So a quick example, if I said y is equal to 3 to the x, and it just wants you to differentiate, it doesn't say show. So if I want to differentiate 3 to the x, I can just remember this rule. Okay? So if y is equal to a to the x, my derivative looks like this. It might be useful if you think about, well, a is just 3 in this question. So the answer would be 3 to the x, ln 3. Okay? One slight extension as well is it might be like a to the kx. So we could do this a very similar process. Take ln of both sides. Bring the power down. Then we differentiate both sides. So that'd be 1 over y. dy by dx. Now be careful with this one. Think about that. It's actually just a number. So k is a constant and ln a is a constant. So that's k ln a. All that stuff is just a number because they're just both constants, aren't they? So that's just going to be one number times by x. So when we differentiate this, we're just left with the number. Okay? So dy by dx would equal y times by k ln a, and y is a to the kx. So we could write that as a to the kx times by k ln a. Very abstract that, isn't it? Let's do a quick example. We'll do one more to finish, to use that result, and then it might make you feel a bit better about it. Okay, last example. We've got y equals 7 to the power 2k, nope, 7 to the power 2x, sorry. So we can just use this result, it's not a show question, so you might want to just realise, well, okay, a is equal to 7 in this question, k is equal to 2, and if you can just remember this, you don't get this in the formula, so you will have to remember it. dy by dx would equal a, which is 7, k, which is 2, and then that's multiplied by k, which is 2, ln a, which is 7. Okay, one last one, little bonus example, which I think might help you remember this, right? If we had y equals e to the x, and we use the same result, so if y is equal to a to the x, we know that dy by dx is equal to a to the x ln a. Let's see what happens if we use this result with something we already know about. I know that when I differentiate this, I should still get e to the x, but let's see. So a in this case is just e, so that's going to be e to the x, and then that's times by ln e. And this comes up quite a lot in maths, you need to know what ln of e is. Okay, sometimes people get a little bit confused by this one. If I said what's ln of e to the x, you hopefully would know that the answer is x, because these functions cancel each other out, don't they? So what's ln of e? Like, what's the power there? Because like if I've got a power, I know that I'm left with the power. If we write e on its own, the power is just 1, isn't it? If you want, check on your calculator. If you do ln of e on your calculator, the answer is just 1. And that's hopefully what we wanted anyway, isn't it? Because dy by dx is e to the x times by 1, which is just e to the x, which is what we knew. Okay. Thanks, guys.